what is a positive definite quadratic form? What property does a positive definite quadratic form have? If we say that this quadratic form is positive definite, then what do we mean by that? More formally, what does it mean to say that A is positive definite? So Van says that if A is positive definite, it can be factored into an upper triangular and lower triangular matrices. So he's being very tricky, but I'm looking for a much more simple answer than that. When A, the matrix A is positive definite, the quadratic form is positive definite, what do we mean? You guys are making this much harder than it is. Or maybe I'm asking it the wrong way.
Every value that you choose for x vector on say
X transpose AX?
Yes.
Or any x has what sign?
Greater than 0.
So if the matrix A is said to be positive definite, then for whatever x you choose, then you're free to choose anything you want. X transpose AX is always positive. If it's semi-definite, positive semi-definite, it means that it's possible to find some non-trivial x's so that q is equal to 0. Either 0 or positive. If it's negative definite, then whatever x you pick, q is strictly less than 0. If it's negative semi-definite, then it's possible to find an x such that x transpose AX is 0, but all the other ones are less than 0. And that's why Mr. Longito was tricking me, because he was thinking about q being above the origin or below the origin. I think it was Van who told me that if A was positive definite, it could be factored into an upper triangular and lower triangular matrix. And actually there's a little bit more to the story, because if A is positive definite, I had an example on the board before where I said A was 2, 3, 1, 1. And that for Q some number, when I plotted it on a piece of graph paper, I would get an ellipse. So that for that A, the ellipse that I get looks like that. Is it possible, by suitable transformations, to create a Q such that y prime A y, where y is the same one, is it possible to find suitable transformations to go from there to there to there? Is it possible to do that? So this last one is Q is equal to Z prime A Z. If you were given a homework assignment, so there was a specific A, that one. We're always free to multiply by 1, correct? It doesn't ever change anything. We're always free to multiply by the identity matrix. It doesn't change it. So we're always free to choose the way we construct an identity matrix, right? So it would be possible to come up with a matrix which times itself gives us the identity matrix, and put that product here and here, so that y is that matrix times x, and then do the same thing over and over again. So it's possible to find a matrix that diagonalizes A. And once we diagonalize A, we get this ellipse. It's then possible to find another matrix that changes the length of the two axes of the ellipse, squashes one down and lengthens the other out, so that we get this. So it's possible, going back to that Liberty Bell example that I just had, where I had SAT math scores and SAT verbal scores, it's possible to figure out how to turn the ellipse, the Liberty Bell, so that the principal axis of the ellipse lines up with the coordinate system, and then squash the bell back into round. So we're going to do that, some of that later on. Oh, in fact, we're coming to it right away.